Good day everyone, I'm James Paul Owerandilia and welcome to my tutorial video presentation. Today, we'll explore one of the most important topics in trigonometry, the right triangle. Right triangles are everywhere, in buildings, ladders, bridges, and even in navigation. In this video, we'll learn what a right triangle is, how to solve for its sides and angles using basic trigonometric ratios, and how it applies in real life. So sit back, relax, and let's begin our mathematical journey. First, what is a right triangle? A right triangle is a triangle that has one angle equal to 90 degrees. It has three sides, the hypotenuse, which is the longest side opposite the right triangle. Second, the adjacent side, which is beside the angle we are measuring. And the third one is the opposite side, which is across from the angle we are measuring. We can use trigonometric ratios to solve unknown sides or angles in a right triangle. These are the sine or sin. Sin x is equals to opposite over hypotenuse. Cosine or cos is equals to adjacent over hypotenuse. Tangent or tan is equals to opposite over adjacent. Now, let's move on to our examples.
In these lessons, we will focus on the basics of trigonometry. And we will start with a review of a right triangle and learn how to label its sides. Then we will discuss the 6 trigonometric functions and learn how to find trigonometric ratios using SOHCAHTOA. And finally, we will apply these concepts to find missing side lengths and angles in right triangles. And let's get started. A right triangle has one angle measuring 90 degrees, which is represented by a small square in the corner. The other two angles are AC, meaning they are less than 90 degrees. Remember, the sum of all angles in any triangle always add up to 180 degrees, so in a right triangle, the sum of the two acute angles is 90 degrees. Additionally, the Pythagorean theorem states that the square of the length of the longest side equals the sum of the squares of the lengths of the other two sides. Please keep these fundamental properties in mind as we progress. A right triangle will label the sides as the hypotenuse, opposite, and adjacent. The side opposite the right angle is the hypotenuse. It is always the longest side of a right triangle. The other two sides are labeled with respect to one of the two acute angles. Let's say this angle is theta, the side opposite. Theta is the opposite side, while the remaining side adjacent to theta is the adjacent side. When labeling a right triangle, start with the hypotenuse, then label the opposite side, and the remaining side is the adjacent. There are 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. These are their abbreviations or short forms of sine, cosine, and tangent are the basic trigonometric functions, while the other 3 functions are the reciprocals. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Each of these functions relates the angle measure of a right triangle to the ratio of its sides lengths. Sine theta is the ratio of the opposite side to the hypotenuse. Cosine theta is the ratio of the adjacent side to the hypotenuse. Tangent theta is the ratio of the opposite side to the adjacent side. A useful mnemonic to remember these trigonometric ratios is SOHCAHTOA. The first 3 letters of SOHCAHTOA represents the sine ratio. S is for sine, O is for opposite, and H is for hypotenuse. This tells us that sine is opposite over hypotenuse. The second 3 letters represent the cosine ratio. C is for cosine, A is for adjacent, and H is for hypotenuse. This tells us that cosine is adjacent over hypotenuse. The last 3 letters represent the tangent ratio. T is for tangent, O is for opposite, and A is for adjacent. This tells us that tangent is opposite over adjacent. The other 3 ratios are simply the reciprocals of basic ratios. Cosecant is the reciprocal of S of sine, so it is hypotenuse over opposite. Secant is the reciprocal of cosine, so it is hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so it is adjacent over opposite. Now, let's work on some examples. Find the values of the 6 trigonometric ratios of the angle theta. The first step is to label the sides with respect to the angle theta. Opposite the right angle is always the hypotenuse. Opposite the angle theta is the opposite side. The remaining side adjacent to theta is the adjacent side. Now, let's use SOHCAHTOA to find the trigonometric ratios. Sine is opposite over hypotenuse, right the opposite side is 5, and the hypotenuse is 13. So the sine of theta is 5 over 13. Cosine is adjacent over hypotenuse, the adjacent side is 12, and the hypotenuse is 13. So the cosine of theta is 12 over 13. Tangent is opposite over adjacent. The opposite side is 5 and the adjacent side is 12. So the tangent of theta is 5 over 12. The other three ratios are simply the reciprocal of these three ratios. Cosecant is the reciprocal of sine, so it is 13 over 5. Secant is the reciprocal of cosine. It is 13 over 12. Cotangent is the reciprocal of tangent, so it is 12 over 5. In this example, we were given the lengths of all three sides. But what if we only know the lengths of two sides? What should we do? In this case, as before, the first step is to label the sides with respect to the angle theta. Opposite the right angle is the hypotenuse. Opposite the angle theta is the opposite side. And the remaining side is the adjacent side. The next step is to find the length of the missing side. Let's call it x. According to the Pythagorean theorem, we know that the square of the hypotenuse equals the sum of the squares of the other two sides. So, for our right triangle, x squared equals 6 squared plus 82. Write that is 36 plus 64, which equal to 100. Taking the square root of both sides, we find the x equal to the square root of 100. Please note that in our equation, it would be plus or minus. They are square root of 100. However, since we are dealing with lengths, here we only consider the positive value as length, cannot be negative. Therefore, the length of the hypotenuse is 10. Now, use SOHCAHTOA to find trigonometric ratios. Give it a try. Sine is opposite over hypotenuse, so it is 6 over 10. If we divide both 6 and 10 by 2, it can be reduced to 3 over 5. Cosine is adjacent over hypotenuse, so it is 8 over 10, which reduced to 4 over 5, right? Tangent is opposite over adjacent, so it is 6 over h, which simplifies to 3 over 4. Cosecant is the reciprocal of sine, so it is 5 over 3. Secant is the reciprocal of cosine, so it is 5 over 4. Cotangent is the reciprocal of tangent, so it is 4 over 3. Now, how do you find a missing side length when a given one angle and one side length? Our first step is to label the sides. With right angle is the hypotenuse. Opposite the 50 degrees angle is the opposite side, and the remaining side is the adjacent side. Next, identify the given side and the side you are asked to find. The hypotenuse is given and we are asked to find the opposite side. Then, identify the trigonometric functions that relates these sides. Using SOHCAHTOA, it is the sine functions that relates the opposite side with the hypotenuse, right? So, the sine of 50 degrees is equals to x over 11. Now, all we need to do is solve for x. Multiply both sides by 11. This cancel out and we get x is equals to 11 times sine of 50 degrees. To find this product, we need to use a calculator. Please make sure your calculator is in degree mode. As the angle is given in degree, type in 11 times of 50. So, x is equals of approximately equal to 8.43 rounded to the nearest 100. Now, let's move on to the next example. First, label the sides opposite the right angle is the hypotenuse. Opposite the 28 degrees angle is the opposite side, and the remaining side is the adjacent side. The adjacent side is given, and you are asked to find the hypotenuse. According to SOHCAHTOA, it is the cosine functions that relates these two sides, right? So the cosine of 28 is equals to 35 x. Now, to isolate x, first multiply both sides by x, then divide both sides by cosine of 28 degrees using a calculator. 35 over cosine of 28 is approximately equal to 39.64.
Solving of angle of elevation in problem with trigonometry, find the height of the tree if the angle of elevation if its top changes from 45 degrees to 60 degrees. As the observer advances 50 meters towards its base, let's say this distance being x, the tangent of the angle is opposite side, divided by adjacent side. So tangent 60 degrees is h over x, and tangent 45 degrees is h over 50 plus x. Tangent 60 degrees is square root of 3.
From this x equals h over square root of 3, tangent 45 degrees is 1. From this h equals 50 plus x, let's substitute x with h over square root of 3, then multiply both sides by square root of 3 to get rid of the fraction. From this h equals 25 times 3 plus square root of 3 meters. That's all. Thank you.